Okay, welcome to KIN 425 for April 2nd. I'm going to be going over 6 article summaries that were submitted for today, and I'll go over each of these briefly just to highlight the most important points from each of these article summaries. So the first set of summaries comes from Dalton, Redar, and Kieran, and they have to do with nutritional supplements that reduce acidosis, and they specifically looked at how these affect exercise in normobaric hypoxia. So normal atmospheric pressure, but with hypoxic gas mixtures, so low fraction of inspired oxygen. This first one looked at the effects of repeated sprint training in hypoxic environments with beta-alanine supplementation. So this was done over 4 weeks. It was 8 sessions of repeated sprint training. And I'm going to go to the whiteboard here to explain the experimental design. So within this, they had 4 groups. They had groups that received beta-alanine supplementation plus hypoxic exposure during sprint training. So this was acute hypoxic exposure during sprint training. They had, again, beta-alanine, but they were at normoxia during the sprint training, and then they had the same hypoxic and normoxic conditions, but with placebo instead of beta-alanine. And then they had placebo plus normoxic training. So they had these 4 conditions, and each group performed 8 sessions of sprint training over 4 weeks. And I liked how the sprint training sessions were set up. It was 5 times 10-second sprints. It was 3 sets. They had 20 seconds of rest between sprints. And then they had about 5 minutes of rest between sets. And the reason I like this was because it kind of, if you think about it, this kind of simulates what hockey players might experience. They didn't mention hockey in this study, but I thought that this nicely simulated perhaps what hockey players might experience during a game. So very high intensity, short duration sprints that are separated by short rest periods, and then 3 sets separated by 5 minutes. So the 5 minutes might be when they're sitting on the bench between shifts. This might be when they're on the ice. So I thought this might be a good simulation. And this type of training was done in these 4 different conditions. And basically, what I'll do before I get into the results here is I'll go over the strength of this design and also explain what the heck beta-alanine is. So beta-alanine is a popular nutritional supplement, and if you take it chronically, it increases a compound called carnosine in your muscles. Carnosine acts as a buffer of acidity, and so if you take beta-alanine on a chronic basis, you get an increase in this carnosine that's formed in your muscle fibers, and it acts to buffer acidosis. So there have been quite a few studies showing that beta-alanine, if you take it over weeks, it's going to help you in high intensity, short duration types of exercise that involve a lot of buildup of acidity. So the other thing I wanted to mention was the strength of this research design. So they had these 4 groups, but when you go to analyze these 4 groups at the end of your study, it's kind of a neat design because you can, it's called increasing the power of your analysis if you have greater participant numbers. So you have a certain number of participants per group here, but essentially you have 2 groups that take beta alanine that you can compare to 2 groups that take placebo. So you're essentially comparing a greater number of participants if you're combining the 2 groups to these 2 groups. And you're also comparing 2 groups that were exposed to the hypoxia during the sprint training compared to 2 groups that were exposed to normoxia. So you get kind of a more powerful experimental design here. So I kind of like this experimental design. So essentially what they found was they found benefits from training in hypoxia and benefits from taking the beta alanine. So both types of interventions had benefits. They looked at a variety of different exercise tests, and they found that either the beta alanine or the training in hypoxia had benefits for the different exercise tests. So I'll have you refer to the journal article summaries to see which specific exercise tests were improved with each of those interventions. But essentially, I think the main take-home message here is that if you're performing this type of training, either doing it in hypoxic environments or taking beta alanine while you did this type of training could help you with regards to your exercise performance and improving your ability to tolerate high intensities where you have buildup of acidity during your exercise. So again, I thought this had good applicability maybe to hockey players. Maybe it would be beneficial for hockey players in the off season to train breathing hypoxic gas mixtures with their sprint training, and perhaps taking something like a beta alanine supplement. I'm just going to refresh my computer here so I can show you the second study that was presented by this group. So the second study had to do with sodium bicarbonate ingestion during acute exposure to hypoxia. So sodium bicarbonate is a supplement that you can take that will improve your acute exercise performance if it's high intensity exercise that builds up acidity. So beta alanine is good to take if you want a chronic improvement, say over weeks, in your ability to handle acidity, whereas sodium bicarbonate is something that you could take right away and it can immediately improve your exercise performance for high intensity exercise that involves a buildup of acidity. So sodium bicarbonate, basically the formula for sodium bicarbonate is Na, so that's the sodium, HCO3, so this is the sodium, this is the bicarbonate. And if this is taken in a solution, you drink it, it dissociates to the ions, in your body. This HCO3 potentially could help to buffer acidity. So if it combined with hydrogen in the blood, then you would end up getting H2O plus CO2. So that's theoretically how the sodium bicarbonate would work to buffer acidity. And it does work. So it does improve your exercise performance during exercise, high intensity exercise that involves buildup of acidity. So essentially in their study, they found that it improved 4-kilometer time trial performance, which would involve a good acid buildup. And they found that it improved it in hypoxia. And there was a dose response. They had 2 different doses of sodium bicarbonate, and the higher doses tended to be better than the lower doses, which in turn tended to be better than were better than placebo. So this was acute exposure to hypoxia, 4-kilometer time trial performance. When you're performing exercise at hypoxia because of the lower oxygen delivery, you're going to have a greater buildup of lactic acid and a greater acidity. So also in this study, they found that the pH during recovery recovered faster under the sodium bicarbonate conditions compared to placebo. So bottom line, sodium bicarbonate is beneficial for buffering lactic acid, and it was beneficial in this study for high intensity exercise performed in hypoxia. So this would have implications if you're an athlete and you're going to high altitudes for sport performance. It would potentially help your high intensity sport performance at high altitudes. Okay, the next couple of studies I have here. Let's go to this one because it still deals with hypoxia. So these studies were presented by or summarized by Brianna and Christy. So this one has to do with submaximal exercise testing at low altitude for prediction of exercise tolerance at high altitude. So this is important for people like tourists that go to high altitude, say for a vacation, to do hikes, and they often have, they don't expect to have trouble when hiking at high altitude, but they could have trouble if they're unfit. So they could experience high altitude sickness. They could experience low exercise tolerance because they're not used to the hypoxia. So in this study, they looked at sea level submaximal exercise testing using the STEP test. So this is a test that you're probably familiar with from your lab sessions. Earlier in your undergrad career, we make you do that submaximal STEP test. With that STEP test, you do increasing intensities of stepping, and you take your heart rate response. And if you have a lower heart rate response to that STEP testing, it tells you that you're in better physical condition. So they found that the submaximal STEP testing using that heart rate response was predictive of your exercise tolerance at high altitude. And they also found that they had the people do the STEP test at sea level. They went to high altitude. They did exercise testing, but they also did a 3 or 4 kilometer hike at high altitude, and then they assessed acute mountain sickness or altitude sickness. And it seemed like the STEP test at sea level, your fitness for that test predicted whether or not you would get altitude sickness during the hike at altitude. So people that became sick at altitude have lower levels of fitness at sea level. So this study shows that a simple submaximal STEP test at sea level can help to predict your tolerance for exposure to high altitudes. Now, the second study that was presented by, I'm going to try to find it here. There we go. This is the second one presented by Brianna and Christy. So this is Live High, Train Low training for 21 days. There's a lot of controversy in the literature about whether living high, training low is beneficial for enhancing your exercise performance. It's been studied for the last 20 or 30 years. The studies are really mixed. This study kind of went all out. They looked at quite an intense training protocol for middle distance athletes. I'm trying to find exactly what kind of athletes these were. They were middle distance runners. and they had them do 21 days of quite intense exercise uh, at sea level, but then they lived at altitude. So the hypoxic exposure at altitude was for 12 hours per day. And then the training was, it seemed like crazy training. It was 4 hours per day, 6 to 7 days per week of running. And essentially, what they found was that this type of training was better than living low and training low for improving um, exercise economy. Um, so exercise economy is just your VO2 for a given work rate at submaximal work rates. So the VO2 decreased for the people that were involved in the Live High, Train Low intervention. Essentially, this is very similar to the concept of efficiency. So you're expending a lower amount of calories for a given work rate. VO2 would represent your caloric expenditure, and that would tell you that you're more efficient. So this is important for athletes. If you want your performance to increase, one way to increase your performance is to increase your efficiency or your economy. So that was one benefit of this Live High, Train Low exercise. They also found that some of the cardiovascular responses were improved in this Live High, Train Low group, more so than the Live Low, Train Low group. So they had a decrease in heart rate and an increase in stroke volume at submaximal exercise intensities as a response to this Live High, Train Low training. So it looked like the cardiovascular changes were beneficial. The only weird finding from this study was that they didn't find any benefits of the Live High, the 12 hours per day of hypoxic exposure. They didn't find any benefits on hemoglobin mass or red blood cells, which you would expect if you were spending 12 hours per day at hypoxia. So they did find improvements in performance in this study, but no improvements in those blood measurements of hemoglobin mass or red blood cells. So a little bit of a paradox there. One other thing they assessed in this study that's kind of an interesting measurement is they used what's called near infrared spectroscopy, or NIRS. This technique is a non-invasive technique to measure your hemoglobin and myoglobin oxygen saturation, and also the desaturation of those compounds in your blood and your muscle. So it's a good measurement of your tissue oxygenation status. And what they've taken from this is called a tissue oxygenation index. So they've assessed this during exercise, and they found that it increased with the group that lived high and trained low. So this tissue oxygen index increased during exercise, and specifically the tissue oxygen index is your, just trying to look it up here. It is a measure of your oxygenated hemoglobin relative to your total hemoglobin. So it gives you an idea of the oxygenation status of your muscle, of your blood and muscle. So this sensor, the NIRS, is usually placed over a muscle group, and then it assesses your hemoglobin saturation, your total hemoglobin within that muscle, within the blood that's flowing through the muscle. So the tissue oxygenation index was greater during exercise after the live high, train low training, which tells you that there was a greater oxygen delivery to the muscle after that type of training. Last two studies I'll cover here. And again, I'm just going to refresh my computer. Keeps timing out on me.